My name is Edward Thompson. I'm a program manager for Microsoft Visual Studio Team Services, and I focus on Git and version control. In this video, I'll introduce you to a technology called pull requests that are a powerful part of a modern version control workflow. First, we'll look at what a pull request is. Then, I'll demonstrate how to use pull requests for code reviews. After that, I'll demonstrate branch policies with pull requests and how you can use them to enforce best practices with your team. Finally, we'll look at using pull requests with forks, which can help enable inner source style workflows within your company. A pull request is a mechanism that integrates a branch of changes into the main integration branch. It's how you request that your code gets pulled into the master branch. And it does this integration on the server in a rich, web-based user interface that enables collaboration with your entire team. In a Git workflow without pull requests, you typically create a new branch, do some work, and make some commits on that branch. And then, when you're ready to publish your changes back to the server, you merge your changes into the master branch, your main integration branch. You do this manually on your local repository. Then, you push your master branch up to the server. Now, if somebody else on your team has pushed changes up to the master branch on the server before you, Git will actually block you from integrating your changes. You'll have to fetch those new changes on the server, merge your coworkers' changes in with yours, and then you can push back up. This is not an ideal workflow. First of all, there's a lot of unnecessary manual integration going on. Sometimes, as developers, we forget that computers are supposed to make our lives easier, and this workflow makes us do a lot of work that could have been automated by the server. But most importantly, with this workflow, code is going straight into the integration branch. There's no code review step. And this is where pull requests truly shine. Let's take a look at a simple pull request workflow. Here I have a Git repository that I've just cloned. So if I want to make a change within this repository, whether I'm making a quick bug fix or doing some more involved feature work, the best practice is for me to create a new branch. So now I've created and switched to a new branch called bug fix. And now I can make some changes to the actual source code. I'm just going to change this markdown file, add an exclamation point because I'm very excited about it, save the file, and once I've made these changes, I'll stage the changes and commit them. Now, at this point, if I were using a naive Git workflow without pull requests, then I would merge this bug fix branch into my master branch. Instead, I'm going to push just the bug fix branch up to the server as a new branch without doing any integration before I do. Now, to actually get my changes integrated into the master branch, I'll open up the rich pull request web user interface. If I go back to Visual Studio Team Services and reload the Code Hub, it actually detects that I've just pushed a new branch, and it encourages me to open a new pull request. So to get started, all I have to do is click the New Pull Request button. This will show me a diff view of the change that I made in my local repository and that I'd like to merge into the master branch. So I can do a quick review of my own code, giving me one last opportunity to make sure that my code is ready to get merged. Once I'm sure that I'm happy with it, I can write a description of the changes that I've made. This helps the rest of my team get more insight into my changes, and it will help to guide them through the code review process. Finally, I'll click the Create Pull Request button, and now my team will have the opportunity to review my code too. They can examine my pull request, look at the changes that I've made, and even comment on the individual lines of code. If they find problems and I need to make changes, I can push new commits up to my branch. And when I'm happy with my changes and my team agrees, I can click the Complete Pull Request button to merge my changes into master. So pull requests are great for letting your team review your code. But again, computers are supposed to make our lives easier. And pull requests can enable a lot of automation around work that can be done by Visual Studio Team Services. This automation suite is called branch policies. Branch policies examine pull requests to ensure that best practices are met. For example, that there's traceability between work items and your code, and that code quality remains high. Let's take a look at some of these branch policies in action. Back in Visual Studio Team Services, in the Code Hub, I can navigate to the Branches page. There, I'll see my main integration branch, Master, and I can select that and open Branch Policies to navigate to the branch policy configuration. Here, I can choose to protect this branch. This will allow me to enable a number of branch policies that will let me enforce my team's best practices. First, I can require a minimum number of reviewers. This ensures that I can't merge a pull request before my teammates have signed off, ensuring that code gets reviewed before it enters production and that the entire team gets visibility into changes. I can also allow myself to approve my own changes. This seems almost counterproductive, but it ensures that everyone goes through a pull request workflow so that the team gets visibility into the changes, even if they can merge their own changes into master. I can select the minimum number of reviewers, in this case 1. Since I'm the only person working on this project, I have to be able to review my own changes and have a minimum number of reviewers of 1. I can add a branch policy that checks for linked work items. This is an important policy, and it helps you understand why code is being written and ensures traceability. A pull request will link directly to the bug that it's trying to fix or the feature that it's trying to implement. I can check for comment resolution. This is a helpful policy to ensure that when somebody adds a comment on my pull request reviewing my code, that I respond to it before I try to complete the pull request and merge the code into production. It's helpful on big projects with large pull requests to make sure that I haven't missed any parts of the review. And perhaps most importantly, I can add build validation to my pull requests. Either using an external continuous integration host or using the great build and release management functionality built into Visual Studio Team Services. I've already got a continuous integration definition set up within VSTS, so I'm going to add a build policy and select it. Now, whenever a pull request is opened, Visual Studio Team Services will kick off a CI build to make sure that my project builds and all my tests pass. If I save changes, we can see this in action if I open another pull request. If I go back to the branches page, I've already got a branch on the server with some changes that I want to integrate. So I can just drop down and select New Pull Request. And when I create the pull request, you'll be able to see the branch policy validation on the left-hand side. First of all, I've got some X's. No reviewers have approved my pull request, and I don't have any linked work items. There's also a continuous integration build in progress. To get through this, the first thing I want to do is add a work item. Once I link to test bug number 59, that build policy is now passing. So I'm able to see the traceability between my pull request and this bug. I can also approve this pull request. Again, on a larger team, I probably wouldn't set it up so that I can approve my own pull requests, but since I'm the only one working on this project, I can approve. Unfortunately, you see that the continuous integration build failed. If I click on it, I can get more information and insight into the failure that occurred. I can look at the build logs here, but if I actually navigate back to the Code Hub and dig into the change that I made, you can see that I accidentally made this little typo. I changed a semicolon into a colon, and now my build fails. So the continuous integration build policy saved me from checking in a breaking build failure into my tree. So it's easy to see how branch policies can help avoid these sorts of problems. Up until now, we've talked about using pull requests as an alternative to pushing directly into a remote repository in order to take advantage of code reviews and branch policies. But what if we can't push directly to a remote repository because we don't have permissions? This is a common situation in open source projects, where you have read access to a repository, but you don't have permission to write to it. In open source communities, pull requests are used along with a technology called forks in order to enable contributions from anybody in the world. And you can use these same workflows inside your firewall, inside your enterprise, on your closed source projects. This is a technique called inner source, and it allows you to take advantage of open source development practices within your company. Creating a fork means that you create a server-side copy of a repository. So even though you don't have write access to the original repository, you do have write access to your copy of the repository, your fork. This means that you can create a branch, make some changes, and push those changes up to your own repository, your fork. And when you're happy with those changes, you can open a pull request to ask the owners of the original project to review your code and ultimately merge it into their project. And even though Visual Studio Team Services doesn't offer hosting for open source projects, it does offer forks for inner source style workflows. Let's take a look. Here I'm back in Visual Studio Team Services, and this is a project within my company that I have read access to, but I don't have write access to it. That means that I can clone the repository and make some changes locally, but I can't actually push those changes back up to the project. I can't create a new branch within this project, so I can't even create a pull request directly. But what I can do is fork the project to get my own copy of it. If I click the fork button, I'm given the option to create a new copy of this project. And when I do, now I have a duplicate of the repository that I actually have write access to. That means that I can make a change to one of these files. I could clone the repository locally, but I can even make these changes right here within the web UI. This is the same rich text editor that's used in Visual Studio Code, only hosted online. All I have to do is click the edit button, and maybe I prefer cross-platform spelled with a hyphen. When I've got my changes, I click commit. And again, this commit just goes back to my fork, which is the only project that I have write access to. Then I can create a pull request back to the original repository. I don't need write access to the project. I don't need to be able to create a branch in the original project. This is completely a separate permission. Visual Studio Team Services gives me a helpful Create Pull Request button. So when I click that, you can see at the top, I'm making a pull request from my fork into the original repository. When I click Create, I'm taken back to the original project where the maintainers or the owners of that project can do a code review on my contribution. They can make notes or request changes and ultimately accept the pull request back into their project or reject it. This is a really powerful way to enable developers throughout your organization to collaborate, and forks encourage code reuse and shared development throughout your enterprise. For more information about Git in Visual Studio Team Services, visit visualstudio.com/learn-git. To learn more about pull requests, visit aka.ms/code review. And to learn more about branch policies, visit aka.ms/branch policies. Thanks for watching, and be sure to follow us on Twitter @VSTS.